what is it about getting the area under a curve using rectangles that on past experience, half of you will get it wrong in the next test, and half of you will get it wrong in the mock, or maybe in the half yearly, or maybe in the waste. The concept is so easy. Let's have a look what I've got here. Okay, I was mucking around my class pad trying to get to do some graphs. We'll talk about using four strips, and we want to get this area here. Oh, this red pen's playing up. We want the area in here. And before we had calculus to do it with, people had to do it by hand, had to draw accurate graphs and graph the whole thing. And I've said here to use four strips. So if I get rid of all that, and I draw four rectangles, I can draw one rectangle there, I can draw another rectangle there, I can draw another rectangle there, and you get the message, and I've got another rectangle there. So what do we do in WA often in questions? How wide is that strip? One. And they'll make it a half or a third or a quarter or something yucky. And I deliberately made sure that this didn't look like a square. I could squish it up and make it look like a square. Because often the horizontal scale is not the same as the vertical scale. We can talk about that, by the way, as the little bit of x, the small change in x. So this one's going to be 1, this is 1, and this one's going to be 1. And then we could look at it, and you do simple things like counting rectangles. What's the actual area of that rectangle there? 1 times 1 is 1. So what's the area of that rectangle? 1 by 2. Or you can just count the boxes. You've got 2. What's the area of the next one? 5. But if you weren't counting boxes, you'd have to go the length times the width, or the width times the height. And so you know that one now. Have a look at what's going on here. That dot is the height for that box. That dot is the height for that box. 5 ones are 5. And then that dot is the height for that box. How many strips are we using? 4. By the way, if I'm using that to estimate that area, how accurate is it? It's wrong there, it's wrong there, it's wrong there by a lot, and it's wrong there by a real lot. So what do we call it? Underestimate. So when it comes to a function though, when we're drawing this with functions and using function notation, people just go and do all sorts of silly stuff. So this rectangle is how? It's 10 high, 10 by 1 is 10. So the underestimate is 1 but plus 2 plus 5 plus 10, which turns out to be 18. You can follow with me on your sheets if you want it. And then you go, oh, different colour pen, I'm going to go black. My red's playing up on these whiteboards. Now we're going to do an overestimate. So by the way, this one here used that dot, and that dot, and that dot, and that dot. How do I get an overestimate? I'm now going to use that dot, and that dot, and that dot, and that dot. So some of the dots get used for the underestimate, and they get used for the overestimate. I'm actually going to start up here for some reason, I don't know why, I just feel like doing it. So that one there, if I come across there and come all the way down, if I could draw that nicely. How big is that rectangle? 17. How can you tell it's 17? It goes up here to 17 and it's got a width of 1, so 1 times 17, or you can count the boxes. So that's going to work my way backwards, that's 17. I go from this one across and come down. What's the width of that box? What's the width? 1. What's the height? 10, so the area is 10. And if you start to look at it, you've got the same numbers turning up. So some of the numbers will be the same. So this next rectangle here will be coming down there, so that's plus a 5. And then the last rectangle is coming down here. And how big is that rectangle? That's 2. So the interesting part is you get these same 3 middle numbers. Those 3 numbers are the same as those 3. And people try to do all sorts of shortcuts. Let's do the numbers. So what have we got for that one? 27, 29, 34. So that's a lot too big. So see how much that's too big there? Often it's nice because that probably makes up for that one there, you understand? One was over by about the same amount as it was. And by the way, if that wasn't good enough, instead of using 4 strips, what would you use? More. Now if they talk about how could you improve the accuracy of it, you can say the words like this: more strips, narrower strips, narrower rectangles. Don't say smaller rectangles. Because what's a smaller mean? Does that mean shorter as well as not as wide? So it's only talking about the width of them and the number of strips. So don't talk about smaller, it's about narrower and more of them. So what do we do to get the answer? 18 plus 34 and divided by 2. So of course what have we got? 40, 52 divided by 2. And that's 26, and if it was centimetres squared, you go centimetres squared and metre squared. And we often, old school, used to write as unit squared. And it's incredible how accurate that is. And in a little while we'll find out how to do that without this process, but they love putting this in the Year 12 exams. But they don't make it ones. They will say from 0 to 2 or from 1 to 3, and they'll go from 1 to 3 using 4 strips. You okay? And then you've got to be careful with your fractions all over the place and what you're going to do with that. Now we've got that one. What makes it different? It's going down. Which 4 points? Actually, we're not for 4 strips. How many points are we actually going to use?
Right.
So we'll need the value above there, the value above there, the value above there, the value above there, and the value above there. I made that one nice. This one isn't quite as nice. If you wanted to, you could say on here that this is 4 too. You could say on here that this is 3 and what? What's it look like? 5.5. This one is 2 and 8. This one is 1 and 9.5. Whoops, terrible writing. 1 and 9.5, and this one is 0 and 10. So to get one of the estimates, we're going to use 0, 1, 2, and 3. To get the other estimate, we're going to use 1, 2, 3, and 4. But what if the graph actually did all sorts of weird things and went up and down and all over the place? Bit confusing of what's over and what's under. But we don't normally go there, we normally keep it simple. So, I could draw in the rectangles. I could start with that one there and go, there's an underestimate. And there's another one, there's another underestimate. And there's another underestimate. And I think it confuses people because sometimes you go under that way and sometimes you go under the other way. Depends on what the graph's doing. Underestimate, this one here, I just look at it and I go, that's 9.5. Can you see the 9.5? I made a simple one by 9.5, so that's 9.5. This one here is 8. This one here is. So really it's the height that gives it away. And the height's called the function value. The height's called the function value. So this one here is 2. Is that an underestimate or an overestimate? And if you couldn't tell, do what you think it is and then compare the two answers. And if I had them in the wrong place, all I'd do is put an arrow and say, swap places or something. So now, how do I get an overestimate? I'm still going to use these points. There's one there. I should shade that whole thing this time. I go, there's one there. I started at the end again. I don't know if I would myself. I think I'd just go across here and come down and go, there's one there. So how big's that one, the big one on the left? Instead of going up to 9.5, now it's going up to all the way up to 10, so that's a 10. The next one will be all the way across there. So that's all the way, let's shade it that way this time. So instead of 8, what's it going to be? 9.5. You guys got the message? I'm going to just keep talking to finish the video, okay? Not because you guys need it. And then if I shaded that one there, it was 5.5 below, but it becomes 8 above. And then the big one here, 5.5 above. And it's going to be interesting to see how it works out. So what have I got? 14, 24, 25. See what I did? I added the 8 and 2 is 10. 20 plus 14. And I'll do the fractions last. This one, I'd go 18, 27, 32, 33. Get the average 25 plus 33 on 2. What have I got? 58 on 2. No mistakes. Josh?
29.
29. Using function values. Slow down. This point here is 1 and the function at 1. So the height of that point is we substitute 1. So in other words, you could have written that as 1 and 2. I didn't write that one first, I should have written it. That one's 0 and the function at 0. Okay? So, all our boxes are really clear and obvious. You might get a question where the boxes are not clear and obvious. So, and the function at 2. Next one, 3, and the function at 3, and the last one, 4, and the function at 4. How wide are all the rectangles? A little change in x of 1, a little change in x of 1, they're all going to be multiplied by 1. So I'm going to talk about the underestimate starting with 0. So it's actually a width of 1 times by the function at 0. Being fussy for a moment. It's a width of 1 times by the function at 1. So this rectangle will go up here to the height of it is the function value at 0. And I could just said numbers, but we've done it already. So what's this one here then? The width by the function value at 2. And the last one is the width by the function value at 3. Now the next one's going to work exactly the same, but instead of being 0, 1, 2 and 3, what's it going to be? Say it for me.
1, 2, 1, 2.
Function at 1, the function at 2, the function at 3, and the function at 4. And by the way, if we did the area from 0 to 2 with 4 strips, instead of having 1, 1, 1, 1, we'd have half, 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 half. You okay? Function values make sense? So what is the function value for 0? 1. What's the function value for 1? 2. And by the way, if I gave you the equation of the graph is?
X squared plus 1.
Thank you. And we could have written that as fx is x squared plus 1. So you could have sat there and gone, put in 0, put in 1, substitute 1, substitute 2, substitute 3 into the function. And how wide is each strip? Nagging about it, 1. So really, maybe we should do this question again. And instead of getting it from 0 to 4, can you get it for me with 4 strips from 0 to 2? I want you to estimate the area. I want you to estimate that area there using 4 strips. And I can just use 0, half, 1 and 2 for one set of answers. And the other set of answers will be half, 1, 1, half and 2. You okay? Can you actually write it for a moment using function notation? So I would start it, I'd say the underestimate's a half times f0 plus a half times. Now, can you shortcut the whole process? Absolutely. You can go half, square brackets. Remember I talk about parentheses and then you go square. So what we call brackets, the rule word's parentheses, whereas this one, that's the rule bracket. But we call everything these days brackets.
So parentheses are those curved.
Yeah. So they are parentheses, they are brackets, and the curly ones which we use for sets of notation are. Whereas that one are parentheses for plural. Yeah? So now, brackets, brackets and brackets. So I could put this F0 plus F1, oh, half. I nearly slipped and wrote F1. Josh, I'm trying to get my brain to concentrate because I'm just going through the motions. Oops, I went the right too many. 4 strips, I only want 4 heights, not 5. For 4 strips, I want 4 heights. And for these 4 strips, I want another 4 heights. What are the heights of the second lot?
Half, 1, 1.5, 2.
Got it. Some of the looks on your face as you're going, yeah, nah, yeah.
Does it have to be 4 strips? Or
So,
can you-
yes, because I said 4. What if I said 6?
You said 4.
I did say 4 a couple of times. If I said 6, you'd have F0, F a third, F 2/3,
I
F1.
was just wondering if, like, in an actual question.
Oh yeah, no, everything you're going to do is going to have it stipulated. They'll often do 3. And they'll say 3 strips between 2 and 3, or, yeah, 4 strips. When you get the 6, you haven't got time in the waste to sit there and do 6. You've got time to do 3. Yeah? And they act like, now for the next one we go, where do we start at? F a half. Next one's F1. So we're starting there, going there, going there, and going there. And we're going to go up and make 4 rectangles. So really, if you want to think about it, we just go up till we hit the line, come across and go down. Up to hit the line, go across, come down. Up, hit the line, go across and come down. Up, hit the line, go across and come down. So there's your question. Get the 2 answers and get the average and write it down. Now, I've told you though that the function is actually x squared plus 1. But you could estimate it on the graph. But what if they don't give you the graph, or they make it unclear? You either go back to the function. So I'm going to start it for you. I said do it, but I keep doing it myself. 0 squared plus 1. So that's actually F0. 0 squared plus 1 is 1. So I've got a 1 there. So F a half is a half squared. I just write a quarter. Plus 1. Plus 1. Are you okay with a half squared? And because of all the kids who can't do fractions, I keep on going. Multiply the tops and multiply the bottoms. 1 times 1 is 1. 2 times 2 is 4.5. Yes, there'll be a couple of people here not great at multiplying fractions. So that's actually 1.25. Next one. F1 means replace the x by 1. Substitution 1 squared is 1 plus 1, so that's 2, which is nice. And the last one. How many people can't do 1.5 squared? F 1.5. Yeah, I would go 3 on 2 squared plus the 1. Multiply the tops and multiply the bottoms. 3 on 2 by 3 on 2 is 9 on 4, which is 2.25. You go. Take the time. So we've actually got 2.25 plus 1, and we've got 3.25. Now you've got to add that up. Possibly without a calculator. How's your maths? Nice as quarters. 1, 2, 3, 4, 5, 6, 7 and 2 quarters. So it's a half times 7 and 2 quarters. Does your brain think of what's a half of 7.5? If you had $7.50 and I said you get half each.
$3.75.
Yeah, you don't think, but when you see this. So then how would I do that though? $3.75. You could just look at it and go 3 3/4. But if you can't see that, how many halves in 7 whole? 14 plus 1, 15 on 2, back 2, multiply the tops and multiply the bottoms, 15 on 4. Yucky numbers. So I am going to keep going on this. So now I've got the same numbers. A half, and F0's 1.25, so you don't have to think. F1 is 2, you don't have to think. F1.5 is 3.25, you don't have to think. Now you've got to figure out F2. How easy is it to get F2? 2 squared plus 1. Just getting too long for a Friday afternoon, or are you okay? How much we got? 5, 6, 7, 8, 9, 10, 11 and a half. So a half times 11 and a half.
6.7. No, 5.75.
Yeah, so 5 3/4. Would you write it that way? If you think it that quick, you can. Otherwise, I do this with Laro thing for junior school. 2 11s are 22, plus 1 makes 23 on 2. So I got 23 on 4. Now I'm going to get the average of those two. All I look at is the average. What's halfway between 15 and 23?
19.
You can add it up and divide by 2.
18.5.
I got rid of this for a second.
19.
Let's do it here.
8 separates and plus 4.
Yeah.
15 on 4 plus 23 on 4 divided by 2. Can you imagine how many people go wrong? Someone with me just goes halfway between those, it's 8 apart 4, so it's just 19 on 4. And the question's done. So we want that on 2, so it's 38 on 4 on 2. I've got to stop laughing. You guys aren't, I'm laughing at myself. What's that?
38.8.
I didn't make any mistakes. All I see is that's even and that's even, so I go 19 on 2 divided by 2 on 1. How do you divide with fractions? Invert and multiply. So the math's got yucky, so that's 19 on 4. So our estimate of our area is 4 3/4. You okay? Let's go back and see if that makes sense. There's 1. See the 1? There's 2. There's 3. There's 3.5. And what's fascinating is how often parabolas end up with a nice number. Parabolas are special. So, what did I get up to? 1, 2, 3.5. So if I put that little bit in there, I'm up to 4. Yeah, you understand what I'm doing? And I want 4 3/4. So if I put those two together here, you can see it's about 4 3/4.